Going live. All right, so review of integration methods from AB Calculus. Let's do this one. So, suggestions. This is a tough one to start with. U sub. That's a great idea. You could go U sub and make this U, but the derivative of that would be then what? Negative 2x? You have like an x up there, but you don't have like a negative 2x, and there's also that thing that's a 3, so that causes a problem. So I heard a suggestion. Split it. Very good. This is a tough problem to start out with. And I think splitting it is the way to go. Very good, guys. So I think you want to go this over this. Then you can U sub it on that one, right? We'll be able to U sub that one. And then plus, I'm going to pick the 3 out in front on this one. Let's see if you guys remember how to do that one. I'll be impressed if you do. Okay, so the first one is U subbable. We already discussed what the U sub was. So U equals 4 minus x squared. So that means du is negative 2x dx. So that's going to become, I don't want to say equals here because I'm not really equal, right? Unless I change these, which I'm not going to do. So let's see. We're going to have like this, x dx should be right there, right? So that's du over negative 2, and then we've got square root of u down here, which is negative 1/2 the integral of u to the negative 1/2, right? So use your integration basic thing that says add 1 and divide by 1/2, which is the same thing as multiplying by 2. Oh, fancy Dan. That's negative square root of u. Okay? So that's negative square root of what? Not u, but 4 minus x squared. And I need to remember that this was a definite integral, so I need to use the fundamental theorem part 1 and plug those things in, which I'll do in a second. Let's do the other integral. I think it's a little bit tougher. So 3 times this thing. This thing should look kind of familiar to you. What does it look kind of like? Arc sine, wonderful. It looks kind of like arc sine. There's only one thing wrong with it. The 4, so you got to compensate like this. Remember, it's going to be plus 3. And how you show it's up to you. I'll show several steps. So you pull out 4 inside. I usually don't show that step that much. So square root of 4 is going to be 2, right? This is going to be the integral of 1 over the square root of 1 minus, and I rewrite this like this. You remember that? Because I'm trying to get it as 1 over the square root of 1 minus stuff squared, so then I can do a u sub with the stuff. So I'm going to have another u sub. I better not call it u, I'll say m. M is that stuff. dm then is 1/2 dx. So this is going to be plus 3/2 1 over the square root of 1 minus, I called my stuff m. And then we've got to compensate. How's that going to go in here? That says dx is 2 dm, doesn't it? So up here, instead of dx, I should have 2 dm. So now that 2 is going to come out and cancel this 2, isn't it? Now we're going to have plus 3 integral of dm over the square root of 1 minus m squared, which is our straight up arc sine. Okay? So here we're going to have plus 3 arc sine of n, which is x over 2, and we've got to evaluate that between 0 and 1 as well. I'm thinking you guys can do the evaluations with 0 and 1, so I'm not going to finish up that calculation. Is that okay? So I want to focus on the integration techniques today. So stick those in with f of b minus f of a, f being the antiderivative that we have here, and you'll be good to go. Let's look at another problem. So that was a tough one to start with, but good, I think. So we're going to be working with stuff a lot like that we couldn't do last year in lessons. The next couple sections. Let's see, what was my next one? Let me find it. So that one was splitting an integral into 2 integrals. This one strategy we should use to integrate that. Which looks pretty scary, I'll give it to you. Well, it doesn't integrate straight out, right? So you want to try some kind of substitution. What should U be? Ideas? I think this is one where you don't see it right away. So this is one where I would say the strategy is picking the right U. That's what I called this strategy, picking the right U. And if you're not having trouble seeing the derivative lurking on the outside, remember, try some things, see what happens. If U is just sine though, the derivative would just be cosine. Do you see cosine? So it's probably not that. So what might be the next most obvious U substitution choice? Natural log of sine would be the next one. So just try it. Don't be afraid to experiment. You're going to have to get used to experimentation if you're going to do higher level math and science. So try it. Pick U as that, see what happens. If I take the derivative of this side, I get U dx. If I take the derivative of that side, I get what? 1 over the stuff. Chain rule. Cosine, what is that? That's cotangent. Hey, I saw cotangent. Did you guys see it? Oh, I think this is going to work, right? So now this is equal, since we don't have limits of integration, we can actually say it's equal to the integral of this part is right there, so that's du. And inside we just have what? U, the most boring integral of all time. How do you integrate U du? U squared over 2 plus c, because it's indefinite. You got it, Kyle. Stick your substitution back in, you're done. So it's the natural log of sine. I'd throw some brackets in, so you can say that's squared all over 2 plus c. So don't be afraid to pick different kinds of U's and experiment with them. Remember, that's going to be something you're going to want to be doing a lot, even in the other sections, because sometimes they're not going to just be like all this method or all that method. They're going to mix them all together, which is good. So there'll be mainly one method, but not all of them. Okay? A lot of the time, a straight up U sub will get the job done. Let's look at another one. I'm dropping stuff all over, sorry. So third example. So we have splitting apart, we have experimenting with the U choice. How about this one? I don't know if I had a real good theme for this one. I think it's just another picking the right U. This one you might need to be looking for a specific thing first. It's kind of close to what? If you just do a straight up U sub, it's not going to work, right? If you make U this, you're going to need like a 6x to the 5th. I don't see any x to the 5ths. You have an idea, Katie?
You make U x cubed.
Ah, U equals x cubed. You guys thinking that if it was x cubed, we've got an x squared on top. That's good, right? So I think that's probably what Katie started thinking about, x cubed. Do you have an x cubed that you might see in there somewhere?
It's 4 minus x cubed. Yeah, you can factor it.
Can't you write the bottom like this? You could factor this difference of squares. I agree with you, Kyle. That'd be one way to get it cubed. Smart thinking. I think you could just rewrite it like this, though, couldn't you? Because now that looks like what again?
Arc something. Yeah.
It looks like arc something, arc sine again, I think, in fact.
Yeah, because the top of it.
All we need is for this to be 1, and we've got like arc sine with a U in it, don't we? So I think it's that kind of problem. So let's see. How should we write this out? Well, let's get rid of that 16, shall we? So if you pull the 16 all the way outside, what's it going to be? 1/4, very good. So then inside we'll have this, and we'll have this, and if you pull 16 out of that, you're going to have to go minus x cubed over something. You need this to be a 16 when it's squared. Because if you put 4 there, it's 16 underneath, right? And if you factor 16 out of this, then you need a 16 underneath. You guys got it? It's a little tricky sometimes, but you guys were doing well with that last year. So, all right, now it's ready to u sub. We could have tried to u sub it on that step up to us. Now u is clearly x cubed over quattro. So du is 3/4 x squared, right? Dx. So that means x squared dx, which I want. Again, missing my notation. X squared dx, like I want, is going to be equal to du times 4/3, right? So now I guess I used red there, so I'll say equals 1/4. This is there, so it's du times 4/3. And this is just 1 minus u squared. So bring your constants out in front, see what happens. We've got 4/3 times 1/4 integral of one we have memorized. So that's just going to be 1/3 arc sine of u, which u is x cubed over 4 plus c. You guys feeling it? Anna, you okay? Anybody have a question? Brandon, you good? So there was another u sub one. Let's look at one where you need to use trig a little more. We're going to have a whole new technique called trigonometric substitution soon. So we'll be doing lots of trig integrals, which I think can be kind of the funnest type. Here's one where you don't need anything special though. Maybe a little bit. How do you do this guy? I call this remember your identities. We learned those and spent a lot of time on them, like these guys are about to embark on, for a reason. One of those reasons is so we could integrate things. So, tangent squared is tempting because there's like some derivative things that are like squared, aren't there? So, derivative of sine is cosine, derivative of tangent is secant squared. So it's not tangent squared though, right? But if we only had a secant squared, we could like totally do this. So is there an identity which relates squared stuff? Well, yeah, sine squared plus cosine squared is 1, and there's 2 other versions of it. You guys have your book in front of you. You can look up the one you need if you don't remember it. I always just rederive it from sine squared plus cosine squared equals 1. I need the one with tangent squared, right? So if you forget it, notice I don't look this up in a book. If I ever needed it, here's what I'm going to do in my head. I want tangent squared. How do I get one of these to be tangent squared? Right there. Tangent squared plus 1 is secant squared. So that means my tangent squared integral can be secant squared minus 1. And I had a 2 here, so I should probably put a 2 here, right? Am I blowing your mind, Brandon?
Mine's already gone. Oh, my arm.
So notice, I didn't remember that. I always mess that one up, honestly. Like, I always mess that one up if I try to just, like, straight up memorize it. So I always do this in my head or on paper. That way I don't mess it up every time, because otherwise I mess it up every time. My wife makes fun of me for it, but I don't care. Whatever. And we know just straight up what the integral of secant squared is, right? It's tangent. And the integral of 1 is x get your plus C. I have a mistake somewhere though. What is it?
You need to multiply by 1/2.
I need to multiply by 1/2 or cut that in half by dividing by 2 because chain rule, right? I didn't write that u sub out, but you could say u is 2x here technically if you want to. That's one where it's just easy to undo the chain. So, good? Okay, so there's one with trig identities. Let's do one more and call it a day, I think. I'll leave you guys with one to work on yourself. So another one with trig identities, which is very similar to one I gave you, and which we'll use in a coming section, is this. How do you integrate sine cubed? I've never asked you to do that before, so not really review. And if you know how to do sine cubed, I think you'll know how to do sine to the 5th, or sine to the 7th, or sine to the 9th, or any odd power of sine if you can do one. You just use patterns. So this is, remember your identities, and use a pattern. Your last question in your assignment asks you to do this, and very useful. Like, this is a very important kind of pattern used in all kinds of wave analysis, various types of engineering and stuff. So very important. But it all starts with the stuff we kind of already know. So sine cubed, the way I'm going to integrate that is peeling. Not peeling a banana, I'm peeling a trig function. So have a look. You can see I'm starting to get excited. Can you guys see it? Like the first time this year. So I'm like, yes, we're almost to the trig integrals, and they're just so much fun. We're pretty much doing it today. So I'm going to peel that sine apart. I want to peel it like this. Why did I peel it apart like that?
Because the integral of sine, because the derivative of sine squared.
Something like that. Yes, Derek's on track. Help him.
Oh. Sine squared is cosine, or 1 minus cosine.
So we're not looking at this one. We're looking at this one. And Kylie said sine squared is, from the thing I wrote down a second ago that disappeared now, 1 minus cosine squared. Just remembering sine squared plus cosine squared is 1, right? Really easy to remember that one. Well, why is that helpful?
Because then you have the thing outside.
Because then you have the what outside, Derek?
The derivative.
The derivative of what?
Of u.
Of u being?
1 minus cosine.
No.
Cosine.
Cosine.
Because that thing's squared.
Good. You're seeing it though. We're all seeing it fluidly. I love it. So I know we're going to do well. Okay, so u is cosine. U is cosine. Du is, careful, negative sine. And that's not negative, but whatever. We can just say this is negative. These parts are du, right? So I guess I'll put it over here. Negative du. And then inside we have 1 minus u squared, which we can integrate easy, of course. So that's the secret to doing sine cubed. The integral of 1 is, of course, a variable, minus u cubed over 3. Oh, I forgot about this minus, right? Better distribute it. Plus c. So you stick u back in. And you get the integral for sine cubed. So there's a new integral. I think you can do sine to the 5th the same kind of way. If you're watching the video, I'd recommend you pause it and try that one on your own. You guys try that one on your own. I think it's going to work the same kind of way. And then after that, we should be able to compare our answers and think about the pattern. So if someone asked us, like your problem's going to ask you, what's the integral of sine to the 13th? Hopefully you can start thinking about what that would look like. So try this one first, though. Okay, I'm going to work sine to the 5th power now, so have a look. So I'm going to split it off, peel off another sine, so I can have my du basically. That's the point of peeling it that specific way. And then you can think about this as the sine of x times the sine squared x squared. You don't have to write that down necessarily if you don't want to. Now you can think about this as 1 minus cosine squared squared And I think the same u substitution works, so I'll do it in red again. So u is cosine, du is negative sine dx. You've got sine dx right there, so just make that negative du. Now you've got 1 minus u squared squared. Which to integrate, what do we have to do? Expand.
Oh.
First thing squared. Last thing squared. 2 of that times that. Yes, here it. Nice. Put a du out, minus du, so minus plus minus du. Now that's going to be negative u plus 2/3 u cubed minus 1/5 u to the 5th plus c. So that is negative cosine plus 2/3 cosine cubed minus 1/5 cosine to the 5th of x plus c. So you might need to do one more to really see the pattern between this and this, but you can see it's going to be negative cosine. We started with 1/3. We're going to have 2/3 here, so the next one might be 3/3. We probably need to do the sine to the 7th power to track it. But you have a question like that, so you might need to do 3 before you can see the pattern. Okay? The last thing I'd like to leave you guys with today, which I'd like you to work on first before starting your assignment, is 3 really similar integrals. And these are the ones in our book, but a good discussion. So I'd like you guys to work on these, and we'll talk about them tomorrow. So compare these really similar integrals. How do you do this one? How do you do this one? And how do you do this one? I think we covered how to do 2 of those 3. For the other one, you might need another strategy, which we didn't see yet. So if you're dying to see, it's the first example in the book, but I'd try them out yourself, and we'll go over them tomorrow to start out with. Otherwise, you guys have your assignment, 8-1, due Wednesday. It's in the book. I mean, it's on Moodle. Okay. See you next time. We'll look at these in the next video.